What's going on, guys? Welcome back to your favorite construction channel. Yeah, and on this channel, if you want any information that's related to architecture, engineering, surveying and construction and all that, anything that is a construction practice, this is your favorite place. Here you're going to get all that kind of information. Yeah, so in this video I want to discuss let me say two of the most expensive, for lack of a better word, most expensive or most sensitive construction mistakes that people do. Of course, not to say that there are two, they can actually even be more than two, because I mean every mistake can be costly in a way, but in this one we are going to focus on only two. The very first one I'm going to discuss in this video has to do with changing the height of the buildings. Yeah, of course, you know, when we are designing buildings, there is always like a standard height of 3.1 meters, 3 meters. Others even can go ahead and do 2.9 meters. But of course, as times change, people are beginning to realize why we need high ceilings. Okay, I'll give an example for this project in particular. This ceiling is about 3.3 meters. Okay, which is just slightly above the standard. But now, if you choose to make that decision when the construction is already going on, it means there are some things that will be affected. For a bungalow, it might be an easy thing, because I mean, before you've done the ring beam, you can choose to raise the height of the ring beam and, you know, make it just slightly a bit higher. Okay, but when it comes to a storage building, the story a bit changes, most especially for the ground floor. If you're changing the height of a ceiling on any level of the building that has stairs, the stairs will be the most affected. And I want to illustrate for you that in this video. Then from that, you will know when that if you're to change the height of a building when the construction is already going on, you will need to know what has actually been affected. Yeah, the consequences of that, you actually need to understand them. Okay, so come on, I show you something. So you see for example, this is the stair, for example, that we have. If you're to look at this stair, we have this distance that comes from here up to here, which is usually about 14 to 15 centimeters. Then we have this distance from here to here, that's about 30 centimeters. You can see if I put my foot here, you can see it fits well. So if you happen to say, or you tell your engineer, or you tell your foreman that, no, I love high ceilings, so I want to change the height of the building, I want to show you how this is going to affect the staircases. So remember, the standard way that we have it is that for a 3-meter building, you'll have 10 meters on the 10 stairs on the first flight, and then on this flight that's coming like this, you also have 10 stairs. So usually there is a total of about 20 stairs. So when there are 20 stairs and you choose to say I'm changing the height of the building, it means you're literally stretching the staircase vertically, which means a riser that we said was 15 centimeters is going to become about 17 centimeters, depending on what height you've actually chosen. So when it becomes 17 centimeters, it's no longer comfortable to actually climb. You realize that when you start climbing the stairs like this as you go up, it becomes a bit comfortable, but you know what you want is to climb your stairs and not even get tired at all. Okay, so when it becomes 17, means every stair has increased by about 2 centimeters. It becomes not very convenient for someone to actually climb the staircases. But of course, you might also argue that you can increase on the number of the stairs. Okay, so instead of stretching these ones to be 17, you could just increase on the number of staircases. For example, here, if they are 10, you could make them 11 and just cover up for that. But if this distance from here up to the end of the stair, from this point where the stair is starting and the other end is not actually increased, it means that while you've increased on the number of stairs, you've solved the vertical issue, but the length has been affected. It means you've now fit all these new stairs into this space, which means even the tread is going to reduce. The tread is basically that length of the length of the stair. This very one here, this one, it's going to reduce also. So it become about maybe 25 centimeters, which might also not become very convenient, because if people have like hills and you're going downstairs and the distance from one stair to another is not enough, it's not really a good thing to feel, you know. That means you have to always tilt your leg or your foot so that both the heel and also the foot how would I call that, both the heel and the toes will actually can touch the same floor, you know. So it's a bit inconvenience, but I mean, people do it and in some scenarios it really should be okay. It's hard to notice, but if it becomes very significant, it's difficult, it's very inconvenient. Okay, so and also the other way, if you choose now to lengthen the whole length of the staircases, that means you're either going to push this whole shaft all the way to the outside, or you're actually going to shift this staircase to this side. Of course, in many scenarios that's not a desirable thing, because buildings are designed with so much precision that if you choose to extend the staircase this side, you'll affect the corridor that someone has planned for people to pass through things here and there. Okay, anyway, it's important when you're having your building designed, you have these conversations with either your engineer or your architect or whoever you are designing with. It's very important you have this discussion, so that when you reach on site, the alterations you're making are not very complex alterations, things of changing sizes of windows and heights of windows. That's really quite a small thing to do. Okay, so the second thing is ignoring the ring beam and the ground beam, whereas in most cases it's obvious for the ring beam. I mean, these days hardly can you find a building that doesn't have a ring beam, but it's also very important. But I've also seen structures where people ignore the ring beam, you know. But the ring beam, and most importantly the ground beam, is something people ignore. Usually when you are doing a storage building, people just want to cast the slab and just take the columns up. Now I want to illustrate for you something. Remember these columns that you see that are holding the slab of the first floor, the second floor, and the third floor, and all that, all those columns that hold them, remember they come all the way from the foundation. So by the time a column has come all the way from the foundation up to the ground slab level, it's already about 2 meters in length. So that column is literally going to go from the ground floor also and go up to the first floor. So that's literally the extra probably 3 meters plus the 2 meters the ground. That's an extra 5 meters. So when you do not put a ground beam, it means that column all the way from up is 5 meters. Now, whereas the cross-sectional thickness of the column, or the cross-sectional area of the thickness, is enough, it's also important that there's some termination somewhere half in the column. Let me just give you an example. I'll just find a stick like this. You'll see that for a stick like this, it's easy to bend when it's loaded because it is long. The same stick, but you can see as I shorten it, if I choose to shorten it and break this part off, it's now even harder to bend. So remember, when the column is loaded, it is susceptible to that bending moment that causes it to fold. So the ground beam kind of creates a construction, a termination from this ground floor up to the first floor. How does that help? It also helps us in increasing the rigidity of the structure in general. This one can most likely be experienced when there's an earthquake. When there's an earthquake, remember an earthquake is actually a horizontal force. So it causes the building to shake to and fro from the sides. Though when you're in a building, it feels as if it's vertical, but it's actually horizontal. And when the building is not well braced in the sides, both on the ground and in the ring beam, it causes it to shift like this, and its lateral strength is compromised because the ground beam was never provided. Also, the ground beam helps in preventing settlement. Settlement is basically when a building sinks. It is normal for a building to settle or to sink, but the problem only comes in when the settlement is not uniform. Yeah, you find one part of the foundation is maybe carrying a bigger load, maybe the part that has tanks, you know, it is because there's a lot of weight on it, it's causing that part of the building to sink, and the other side is not sinking. That is what will cause a breakage. But when there's a ring beam, it kind of redistributes all that force that is from the tank stand, it redistributes it all around the building. That is not locally. It's not locally experienced by just 1 or 2 or 3 columns, but by the entire structure. So it keeps the structure all together. So the next time you're building, make sure the ring beam is incorporated in your building. You might not see it now, or even in the near future, but maybe when something strong comes, maybe strong winds, maybe strong earthquakes come, it will be quite sensitive. It will be quite painful when everyone's house in the neighborhood is okay and yours has a crack. Okay? So anyway, those are the most 2 sensitive construction mistakes that I believe we need to talk about today. We'll be talking about more even in the next videos, but I just thought it was important to talk about this. So thank you very much guys for watching, and I hope you've had a lot to learn. Have a good time.